Welcome to Study Loop.
Okay, what we need to do is we need to find the bond energy between two carbons that are bonded together with a triple bond using the combustion of acetylene gas. So the first thing we're going to do is we are going to write down the actual equation. So we have C2H2 plus O2 produces CO2 plus H2O. And what we want to do is we want to, and then we'll hold on, the enthalpy, delta H, is equal to 1259 kilojoules. Now, they don't specify in this problem if it was negative or positive, but it is an exothermic reaction, so we have to make the assumption that this is a negative delta H, which is 1259 kilojoules. Now, it's talking about bond energy, so what we need to do is we need to know the Lewis structures for each of these compounds. So for the C2H2, we have H bonded to a C, triple bonded to a C, bonded to an H. Then for O2, that's a double bond there. And for CO2, we have two O's double bonded to a carbon, and then H2O. All right, so now what we have to do is look at our bonds. We have an HC bond, but there are two of them. And we have a CC triple bond, and there's one of those. All right, now what we need to do here is we need to balance this. So this delta H is for 1 mole of C2H2. So we got to keep this as 1 mole. So we have two carbons, and we're going to put a 2 there for two carbons. We have two hydrogens, and then over here we have 4 oxygens, 5 oxygens. So I'm going to balance this with a 5 halves because 5 halves times 2 is 5. So that means we have a double bonded O to another O times 5 halves. And then over here we have 2 of these, which means we have 4 oxygen double bonded carbon bonds. And then over here with H2O, let me make my H a little better, we have an HO bond, and that's going to be times 2. And all of those should add up to this enthalpy value. So now what I'm going to do is I'm going to have in my equation. So my first thing is going to be my H hydrogen carbon bond. And looking up on that table of bond energies, I have a value of 414, but there's 2 of them, so I'm going to multiply it by 2. Then we have the carbon-carbon bond, but we don't know that one. That's what we're looking for, so I'm going to label that as X. Then I have the double bonded oxygen. So the double bonded oxygen is a value of 498, but I got to multiply that by 5 halves. Now, on the other side of the equation, we are not breaking apart bonds, we are forming bonds, which means the energy is negative, so I'm going to subtract those. I have, if I look up the carbon-oxygen double bond, that is equal to 715, but I'm going to multiply that by 4. And then I have the hydrogen-oxygen bond, which is 464, and I'm going to multiply that by 2, and all of that adds up to a negative 1259 kilojoules. So when I solve for X is equal to 1002 kilojoules. All right, which, if we look at the value in table 9.2, we see that value is actually 820, which is much higher than what the actual value is. All right, in part B says when 500 grams of acetylene burns, how many kilojoules of heat are given off? So I'll change colors here for new part B. We have 500 grams of C2H2, and this value here is the amount of heat per mole. So I'm going to change this to moles by multiplying it by 1 mole of C2H2 has a mass of 26.02 grams. That gives me the moles of C2H2. And then what I'm going to do is I'm going to multiply it by a negative 1259 kilojoules for every mole. And when I do that, my grams cancel out, my moles cancel out, leaving me with kilojoules. And that is going to equal 24,000, or how about scientific notation? 2.419 times 10 to the fourth kilojoules. All right, there's B. All right, on to C. C is asking how many grams of CO2 are formed. All right, so we're going to make the assumption that we're still using this 500 grams of acetylene. So I have 500 grams of C2H2. Once again, I'm going to change it to moles. 1 mole of C2H2 has a mass of 26.02 grams. And then I look at my mole ratio from the equation. For every 2 moles of CO2, I have 1 mole of C2H2, and then the molar mass of CO2 is 40. Let's rewrite that. So we have 44.0 grams of CO2 in 1 mole of CO2, and that is going to equal 1,691 grams of CO2. So there's your answer to B. I'm sorry, C. Then on to D. All right, how many liters of O2? Well, once again, we're going to make the assumption that we're starting with 500 grams of C2H2, and we're going to change that to moles. Again, 1 mole of C2H2 has a mass of 26.02 grams. Then we have 5 halves O2 for every mole of C2H2. That's from the balanced equation. And that is equal to 48.02 moles of O2. Now that gives us the moles. They are asking for the liters. So of course we're going to use PV equals nRT. So our volume is going to equal 48.02 moles times 0.0821. That's the ideal gas constant for atmospheres. And then times the temperature. They tell us the temperature is 298 Kelvin. And divided by my pressure, which is 18.0 atmospheres. And my volume is going to equal 65.30 liters. And there we go.